Hello and welcome to this little lesson on timers in Siemens TIA Portal. If you've ever worked with an on-delay timer in a traditional hardwire setting, then you get the basic concept of an on-delay and off-delay or a one-shot pulse or some type of timer like that. And here is what the program looks like to do a timer. And there's the hard part is that Siemens does things a couple different ways. And it's just your preference. But both of them work the exact same way. It's just a matter, again, of your preference. I prefer one way. I'll tell you which way I prefer in a second, but that doesn't mean that you can't use both of them. One is more of a legacy instruction. One is more of a modern instruction that's a little more clear. But just where I find my Siemens timers is over here in basic instructions. You'll see timer operations over here in the far right. And if I expand that drop down menu, you'll see TP, TO, TOF, and TONR. Each one of these has a specific function, and you'll see that this repeats down here. So all of these are set up just fine, for you to use. But here we go. This TP is what they call a pulse timer. So it can take a momentary pulse, momentary input, and make sure that it will pulse out a certain amount of time. We'll show you that in a second. TON, that's a timer on delay. Works just like a time where unlike the pulse timer, that once you drop out your trigger or your input to turn on the timer, the pulse timer will continue timing. The on delay will make you keep a input sustained to the input of the timer to power the timer until it reaches its end of time preset. That's a timer on delay. A timer off delay, what that does is once you activate the input bit and make it true, it's going to switch states or switch something on. Once you drop out that input bit, it's going to then start timing to turn something off. The classic example is like lights in a lab. Once the last person leaves, the lights will stay on for like 5 minutes and then they shut off to save time, or an exhaust fan in an application. And the last one is a timer on retentive. When the traditional timer on drops power to the rung, it will automatically reset, where the timer on retentive will keep its time until a reset command is activated. Okay? So that's how the basic timers work. And here we got a simple program set up. Now I just have some hardwire switches and some outputs to turn on. Just going to name them input 1, input 2. But before we get started, something you'll notice that you may not have seen before is this right here. It says DB1. Now circle it right here. Typically, our addressing has been I0.1 for an input, or a memory bit is M0 something, depending if we create a string of bits through a word. But we haven't seen potentially something called a data block before, and that's what the D stands for, is data block. This is how Siemens stores all of the information for timers, okay? Because it needs certain types of data to store the time elapsed, the preset time, the on and off data for it to operate appropriately. Now, we'll talk about creating data blocks in a second, but let's just humor us first. We'll walk through the whole setup. But here's the timer on delay. The in is what conditions go true to start the timer. So the in is what is basically akin to what makes it time. The PT is a preset. Now, here's one cool thing about Siemens timers. I just put 5 seconds. Well, I can also put 5 milliseconds, and it's going to time for 5 milliseconds. I can also say 5 minutes if my computer was slow enough to get caught up. Oh, syntax error. So 5M. Sorry, let me do M. So 5M, 5 minutes. Or I could do 5 hours. So there isn't a preset base to Siemens. You can have it set for what you want. I'm just going to do 5 seconds because I don't want to wait forever. And there's an elapsed time output as well. So you can create our good old-fashioned memory word here, MD3. That's my elapsed time. If I go into show all tags, you'll see a elapsed time, and it's a MD3. It's a memory. It's a word. So it's operand type or double word in this case. Cool. So anyway, so I don't need to put anything there. I did just so I could put the data somewhere. And then now Q is your output, just as consistent as before. And when this is true, this will power this output here. This is one way of programming this. Now you could do the same timer. You don't even need this output here. You could instead use the name of your data block .q for the Q bit, and you could power on an output as well. Or when this is enabled, or when this is, when you have enabled to the timer, you could have that bit set up as well. So how does that differ? So let's show you how this is done. So let me go online, and then I can hit the little sunglasses. Or let me download, because when you got orange over here in blue, remember that means it's inconsistency. So let me download, because I might change something since the last time I downloaded it. Now everything's green over here, and now I hit my sunglasses to monitor, and you can see nothing is working. But if I flip on input 1, you'll start to see the timer timing. You see the lapse go here, and you can see down here, output 3 gets turned on. And now that since it's done timing, output 1 is turned on, and if the Q bit is true, output 2 is turned on. So let me turn off that switch and watch, everything drops out. So if I flip on input 1 again, it starts timing, output 3 turns on because that's enabled, but if I drop it out, look, everything resets again. One more time, you can see output 3 is being turned on, and when it reaches 5 seconds, output 1 and output 2 does get turned on. But I don't need output 1 here. I could actually delete this. So if I stop monitoring, yes, I want to go offline. Delete, download, it won't give me an error in this case. So let me go back to monitor. And so now, once again, turn things on. Wrong switch. There we go. And you can see the output 3 is on because it's enabled, and then once it gets to the time, output 2 turns on. So you can power outputs either way by putting an energized output here or using the Q bit right here to program off an output. It's dealer's choice, but it creates some good flexibility. Now the other timer way of doing it is this is the more legacy version. You still need a data block. In this case, I just called it timer 1, but instead it doesn't have the input in the Q and the elapsed time. So that's all there, but it's hidden. It's not as clear. It's kind of behind the scenes. But here's an input, and it will power on the timer. It's a timer on, same base amount seconds. That's always down at the below, and then I address where I want the data to be stored in my data block. But again, I have a Q and I have an input, so that works exactly the same. And so if I power on my input, you can see it starting to time. The timer in is active, and then when it hits 5 seconds, the output turns on. And to reset, just turn off input 1. It drops power to the timer, and boom, it resets. So the function works the same, just the programming is different. You may see this out in industry because some old timers that were used to 300 or even before, the legacy PLCs, they'll still use this, and that's why they keep them around. But if I haven't tipped my hat, I like this way better because it's more function blocky, and I just like seeing where things go. So how we set this up? So I'm going to set up an off-delay timer. So now we've seen the function. Let me set up a timer from scratch. So I'm going to go offline. We know how they function now. And I'm just going to go in down to network 3. And I'm going to use output 7 and 8, or 6 and 7, and switch input 2. First things first, if I'm doing it with a new programming, the minute I drag over an input or drag over the timer, it's automatically going to prompt me to create a new data block. All right, and it's automatically going to address it something new. That's kind of nice. Now remember, I'm going to delete this. I can also create an unknown box, so my question mark box, and just go in here and type in TOF. And look, and hit enter, and it will show up. And once again, it will say, hey, do you want to create this data block? This is the other reason I like the newer way of programming. I hit OK. Everything's hunky-dory because it's IEC timer 0 data block 1, and you'll see it showing up under here. So if you go, you might look here, and if you kind of look under system blocks here on the right, under OB1, it will expand. You'll see program resources, and look, here's all my data blocks and my different names: OC1, DB1, DB3, DB2, etc. Okay, so I can keep this on, but I don't really want to because it's an off-delay timer. So let me just to mix things up, let me do examine off, and I'm going to do input number 3. Okay, input number 3, not being used elsewhere. And my preset, I will make it timer equals 5 seconds, or I can just type in 5 seconds, and it will automatically populate. I don't need to put anything for elapsed time, and there's my cue. Just for the sake of ease, I am just going to drag that in, and I'm just going to say output number 6. Boom. But I want to know when it's timing, so I'm going to go here. And when DB timer data block 1 is in timing or is enabled, I can do this. Oh, output 7. That's not being used. Okay. So in and on. There we go. There's our new setup. Let me hit download and compile. Hit load. And let me hit the sunglasses and go online. And now I have outputs on because everything's enabled because I'm using a normal examine off switch. So if I turn off my switch, you can see the input side drops out, but you can see this is timing. Now my output turns off. Kind of cool. Close the switch. You can see it turns off, but nothing is timing. And now I drop power to the wrong end. There it goes. Everything turns off. All right, that's how you set up a timer from scratch. That's how an off-delay timer works. Let me go offline. I'll show you the legacy version of it. So here's an off-delay timer. And notice nothing gets created. Oh, darn. What do I do? If I want to create a block, up here where it says Add New Block, let me click on Add New Block, and then it's going to pull up this menu. Do I want another organizational block, function, data block? Well, we'll get to these in another live, but I want another data block. Well, do I want it global, or do I want one of these? Well, I'm creating a timer, so I want to call it a timer. And I'm going to automatically label it. So it's important that you give it a type if you want it to be a timer. And I'm going to call it TOF1 just because. Hit OK, and now you'll see it shows up here, and you can see the are you, you're in, you're off, your established time, your preset, all that fun stuff. Okay, you can also make it visible if you want. It's false and other fun things if you edit. But anyway, let's go back into our OB1 and we can do some editing. Let me erase all drawings. So there's my tee off. I'm going to I can drop and drag it right there, and it does it, and I can just give it 5 seconds. Works just like the other one. Except now I'm going to do a switch, and I will do input, I don't know, 5. What the hey? And once again, I took off a light here, so I'll do output 1. And if I want to, I just click on this, highlight all my tags. Here's my TOF, and here's my Q. So when it's done timing, or not done timing, when it's done timing, it'll cut out. So now here's how the legacy timer works. Hit my sunglasses. Put input 5 on. Switch the states. Turn off, and you can see it starting to time. And once it reaches its accumulated or its preset, it turns off. Fairly simple. So this is how we work with these legacy setups. And this is how you create things from scratch. So let me go offline, and I'm just going to, just for the sake of show and tell, I'm going to turn this into an examine on, and I'm going to turn this into a pulse timer. And let's turn these into pulse timers just to show you how it's done. I'm going to download. Since now we know how to make timers, I'm going to turn these into pulse timers. And now, if I hit my sunglasses, you can see how these work. So the pulse timer, I hit 2, and I flip it off automatically, but see, it's still timing. It's still timing, the output stays on, then it turns off. So as soon as it gets input, it'll turn something on for a short amount of time. So watch that again. So input 3 on, off immediately, and now it stays on, and now look, it will turn off in 5 seconds. Let's look at number 4. Same thing. And you can see it's green, powering on, now it's off. So this is how a pulse timer works. Momentary input activates a timer, and then when it's done timing, it will turn off because it's just going to pulse for a certain amount of time. But what happens if I keep this on? So if I keep on input 4 for past its set time, it works just like it will turn off, but it won't keep timing. I need to cycle on off in order for it to time again and reset. See that? I actually like using the pulse timer at times because there's things I just want to turn on for a moment or send a signal. So that's a pulse timer. And last but not least, let's show you the other timer, the retentive on-delay timer. I'm going to go up here and turn this one into a, now this here is your reset bit. All right. You don't have to program anything, but you can just put in another bit there. And so now, when this is true, it will reset to your preset. So, and remember, since this is retentive, and I'm trying to make it easy, and let's just do 30 seconds. Okay? It's going to store this time, again, and the timer done. So here's the legacy version. I can turn this into a retentive. I'm going to do 30 seconds, but here's the glitch, is if I want to reset it, I need a reset command. So reset timer. And now I want to reset timer 1. No, it added a period. Hold on. There it is. I just dropped and dragged. So it kept adding that period. All right. And I just put a switch in, and I will call it input 7, because we haven't used input 7 yet, I don't believe. All right. Download. Overwrite. And now here we go. Everything's live. When I toggle the bit, you can see it starts the time. I stop. Boom. It's still time. It's still remembering the time. Keep going. Boom. Still timing. Still timing. But if I let it go, it'll eventually get to 30 seconds as we speak. You can see it go up, but it's remembering its time every single time I drop power. So as it goes up, you can see that it won't hit the, it's going to hit any second now, literally in any second now. And then boom, 30 seconds, output's on. If I drop my input, guess what? It stays on. If I try more, it's not timing. What do? This is where we have the reset. Hit reset, everything resets back to normal, and now I can time again fresh. If I reset, it's going to automatically, even if it never gets to that input. Same holds true for this setup. I'm going to hit input number, and you can see it's starting to time on this setup here. And it's going to keep going, and until it hits a certain amount. I should have made this 10 seconds. So let's see, 10. Download, because that'll be easier. And so now it still remembers the 8 seconds and milliseconds. If I turn on this bit, boom, it's been timed. But now, what do I do? I gotta hit reset. And now it goes through, then it resets. So there we go. Timing, drop out. Timing, drop out. I think you get the gist. You can use either one. Either one's appropriate. But again, you know which one I have a proclivity of, because I like the function block looking timer. It makes more sense to me. I can see everything. It's more intuitive. But this is how your timers work. And one last thing, let me change this. I'm going to go offline. And I'm going to change this back into a timer on. So this is just some random input. I'm going to delete it. If I want to, so some of you might say, well, I like Alvin Bradley because that's a TT bit and this is just the enable bit. Well, if I want to do that here, if I want to have something turn on when it's timing, and it's timing alone, this is the workaround to do it in. Okay. And you can see that. I'll download this. Go live. And you'll notice that this will only turn on while this is actually timing. Once it hits its end, whoops, it's going to cut out, so it's no longer timing. See, so that is a mimic for the TT bit in Allen Bradley. If you're used to that, is just put these in series so you have your Q and your N enable. So I hope this was educational. Please let me know if you have any questions. Thanks.